Hi, this is Stephanie. I'm going to work through some problems from section 3.3. I got a request for about 4 of them, so this is the first one. I'm going to be doing question number 7. So I'll share my screen. Okay, and open up. There we go. Okay, so we've got 3.3, number 7. So it says in exercises 7 and 8, use long division to verify that y1 equals y2. So what this means is that we're starting with a rational function y1, and we're going to use long division to divide that out into y2, where we're going to get a polynomial, x minus 2, and then a remainder, which is 4 over x plus 2. If you don't get that when you do the long division, that means you made a mistake somewhere, because that's the whole purpose of verifying this, is making sure you're doing the steps. So I'm going to start by setting this up. So the top of the fraction, x squared is being divided, or x plus 2 is being divided into x squared. So I'm taking x squared, dividing it by x plus 2. Now when we do long division, and this is the same thing for synthetic division, you want to make sure that you have a correct number of terms. So if I have an x squared, I need to have 3 terms written down. If I have like an x to the 5th, I would need 6 terms. So you have to make sure you count down your exponents. And so these are going to be placeholders. So I have x squared, and I'm going to just add in plus 0x and then plus 0. Sometimes you don't need these, but most of the time you do. So it's just good practice to put those in. Okay, so when we start with long division, it's very similar to when we divide by numbers. So I will just take some random, let's say I'm dividing 365 by 4. So actually, let's divide that by 2. Make this a little, okay. So you say, okay, how many times does 2 go into 3? Goes in 1 time. You do 1 times 2, which is 2. You subtract, you get 1. You drop down your next number. And then you repeat the process. So we're going to do something very similar here. This time, we don't have numbers, so we have our variables. So we're going to say, how many times does x go into x squared? This is the same thing as saying x times what gets you x squared, or thinking the other way around, x squared divided by x gets you what? And usually thinking about it as a division is easier, because then you can use the rules of exponents. So x squared divided by x, the x has an exponent of 1. When you're simplifying, you subtract your exponents, so that just gives us an x. So that gets written on top, just like when we wrote the 1 on top with that example with the actual numbers. And then in our example, once I had figured out it goes in 1 time, I did 1 times 2. So we're going to do the same thing here, but we're going to do x times the x plus 2. So we're going to distribute x times x plus 2. So I like to write my work off to the right, unless you can do it in your head. But doing it this way, it's a lot easier to see what the math was that you did and if you made any mistakes. So I start with x times x. That gives me x squared. And then x times 2 is 2x. So just like regular long division with numbers, we write that underneath. But I have to make sure that I line everything up with like terms. This is why we have to put the placeholder, because otherwise I would have nowhere to line that 2x up with. Now, with regular long division with numbers, we subtract. When we start subtracting here, sometimes we're subtracting negatives, which end up in addition. So another way to think about it is just change the signs. And when I do that, I like to circle them so that I know that I've actually actively changed those signs. There's a little rhyme to remember this. Draw the line, change the signs, and then combine. So you add them going down. So x squared minus x squared is 0. And then 0x minus 2x is minus 2x. And then I'm going to drop down my plus 0. So now we've done the same process that I did with the number, where I ended up with 16. And when you do that again. So if I look at my 365 divided by 2, how many times does 2 go into 16? It goes into it 8 times. 2 times 8 is 16. Subtract, I get 0. I drop down my 5. And that ends up being, we keep going, 2 goes into 5, 2 times 4. 5 minus 4 is 1. And now that's a remainder. I have nothing more to drop down because that's where the decimal place is. So that'd be a remainder of 1, which we could write as 1 over 2. So our answer is 182.5. So it's a similar process with the long division of polynomials. So for my second step here, instead of looking at that x squared, now I'm going to look at the first thing out of what we have remaining. So I have a minus 2x, and then I'm going to look at that x again. So we're always looking at that first term. So because it's easier to think about this as division, we have negative 2x divided by x. When you divide those, your x's cancel, so we have negative 2. So then I write down on top, negative 2. And now I need to then distribute, and this time I'm distributing the negative 2. So negative 2 times x plus 2. So negative 2 times x, that is negative 2x. Negative 2 times 2, that's negative 4. So I'm going to write that underneath. Negative 2x minus 4. Draw the line, change the sign. So this is where all the negatives become positive, and then combine them. So negative 2x plus 2x is 0. 0 plus 4 is 4. And that is our remainder because x times something, we would have to multiply it. We can't really multiply that by anything to get rid of an x. So that gives us, our whole part is what's on top of our long division. So that's x minus 2. And then the 4 is our remainder. And because we're dealing with polynomials, we have to make sure we put a plus. So plus 4, and then over your denominator, what you were dividing by, x plus 2. And you'll see that this is the same as y2, which means we did this correctly. And dividing y1 gives you y2. So hopefully you found that helpful. I like doing long division of polynomials because it's just an algorithm. You just kind of go through step by step by step. You know, as long as you know the rules of exponents and you can multiply, it's pretty easy. So I've always enjoyed it. So hopefully this helped. And you can see it's not as scary as it may seem. So, all right, bye-bye.